Okay, so now let's talk about the double angle identities. This is where you might have something like the sine of 2 alpha. So some angle that can be written as twice of another angle. If we were to derive these, pretty much what you're looking at, if this is supposed to be 2 alpha, that would be alpha plus alpha, which means that you could use your sum identity where you replace beta with alpha because they're both the same. So if we use our sum identity for the sine, we would have the sine of alpha cosine alpha plus cosine alpha sine alpha. And notice that these two expressions are the same. So really, it's when we combine it, we get 2 sine alpha cosine alpha. And that will be the first double angle identity. Now the second double angle identity for cosine alpha plus alpha, if we apply our sum identity, we get cosine alpha minus sine alpha sine alpha. And if we simplify this, that's cosine squared alpha and sine squared alpha. So there is our double angle identity for cosine. The thing is, though, cosine, they go a couple extra steps and simplify this expression into something else. So you need to be able to remember what those two other expressions are for the double angle of cosine. So the first one is, what if we replaced cosine squared alpha with 1 minus sine squared alpha? That's using our Pythagorean identity. So if we did that, this turns into 1 minus sine squared alpha, and then we still have the minus sine squared alpha. These two combine together to give us 1 minus 2 sine squared alpha. Okay, so that's one of the alternate expressions. The second alternate expression goes back to this original one, and instead of replacing cosine squared, we're going to replace sine squared. So if you recall, sine squared is 1 minus cosine squared. So what that turns into is cosine squared alpha minus the quantity of 1 minus cosine squared alpha. And if you don't forget the quantity part of this, when you distribute, you're going to get a different answer, right? So distribute your negative, and you get cosine squared alpha minus 1 plus cosine squared alpha. These two combine to give you 2 cosine squared alpha minus 1. Okay, so here's the 3 identities for cosine 2 alpha. There's the one for sine 2 alpha. Let's do tangent. So tangent of alpha plus alpha. Well, that's going to be tangent alpha plus tangent alpha divided by 1 minus tangent alpha times tangent alpha. So let's simplify that. We get 2 tangent alpha over 1 minus tangent squared alpha. Okay, so to pull it all together, here is a list of all of your double angle identities that you need to recognize. So when you go to use these things, say you had something here like the sine of 60 degrees, well, half of that angle is what you're going to be plugging in here for alpha, because this is considered 2 alpha. So you'll have to kind of think about that a little bit. The angle that they give you is not the angle that you're plugging in here. You have to take half of it to plug it into your identity. So let's take a look at an example. So what if they tell you that the sine of alpha is 4 over 5, and they ask you to find the cosine of 2 alpha? They don't give you what alpha is, and we don't care what alpha is. We just are going to plug it into one of our 3 identities. And you get to pick which identity you want to use. And since they've given us sine of alpha, I would probably choose the identity that only has the sine of alpha in it, not the one that has cosine as well, because if you do, then you have to go through and figure out what that is. So let's use the one that says 1 minus 2 times the sine squared alpha. So we just plug everything in. We square the 4 over 5, multiply by 2, change the 1 into 25 over 25, and then we get an answer of negative 7 over 25. Okay, we are also going to do some proofs in this section. So let's take a look at this proof. When you have a double angle expression in a proof and it's cosine, you probably don't want to jump right in and pick one of the three to rewrite this as, because you don't know how this side is going to get simplified. So let's just work on this side first of all, and then see what it comes to. So hopefully the first thing that you see down here, the denominator, this is our Pythagorean identity, 1 plus tangent squared alpha should equal secant squared alpha. So we can replace that. The next thing that we're going to want to do is to convert tangent into sine over cosine. So we get 1 plus sine squared alpha over cosine squared alpha divided by secant squared alpha. Maybe you wanted to do this at the same time, or you do it as a separate step, but secant squared alpha in the denominator turns into cosine squared alpha in the numerator, and so that's going to get multiplied to this expression. And then when you distribute, you end up getting cosine squared alpha minus sine squared alpha. So this, if you recall, is one of the three double angle identities for cosine. So that means that over here we can turn this into cosine squared alpha minus sine squared alpha, and you're done. Okay, so that is the list of your double angle identities, and you should get some good practice in utilizing them. All right, we're done. Bye.